Let's review unit rate from grade 6. The unit rate in proportional relationships can be found by dividing the value of the dependent variable by the corresponding value of the independent variable. For example, if we know that 3 sodas cost $15, we understand that the cost depends on the number of sodas. So cost is the dependent variable and number of sodas is the independent variable. We can find the unit rate by dividing $15 by 3 sodas, which tells us the unit rate is $5 per soda. Proportional relationships can also be shown in a table of values. We can find the unit rate by calculating the constant ratio for each pair of entries. Each ratio simplifies to the unit rate, $5 per soda. We can also see the unit rate in a graph. Remember that in a proportional relationship where we have a straight line going through the origin like this one, the point when the x value is 1 shows us the unit rate. So here we see the point 1, 5, which tells us the unit rate is $5 per 1 soda. Technically, we can use other points too, but we have to simplify. So if we use this point here, 7.35, we divide $35 by 7 sodas to also give us $5 per soda. Finally, we can find the unit rate in an equation by looking at the coefficient of the independent variable. So in this equation, the unit rate is 5, or 5 over 1, which in this situation means $5 per soda. This also should look familiar from grade 7, when we learned about the constant of proportionality. Let's talk about slope. When you think of the word slope, you likely think of a mountain. Perhaps you think of a ski slope. A slope is something with an incline or decline, like this ski slope. We might say that the top part of the ski slope is steep, meaning it has a large incline. And we might say that the bottom part of the slope is less steep because it has a smaller incline. As it relates to math, we start by defining the slope as the steepness of a line on a graph. Let's look at the graph of the line formed by the cost and soda situation from before. This line definitely has an incline to it, as we see that it goes up from left to right, telling us that as the number of sodas increase, so does the cost. But how much does it change as it goes up? That is the slope, a value that defines how steep a line is, and this value is the ratio of the vertical change over the horizontal change, often called the change in y over the change in x. It's the rate of change between the dependent variable and the independent variable. So let's pick any 2 points on this line. Now we'll find the vertical change, or change in y. The y values increased from 15 to 35, which is a change of 20. Next, we find the horizontal change, or change in x. The x values went from 3 to 7, which is a change of 4. Now that we have the values reflecting the changes, we make a ratio of the change in y over the change in x, 20 over 4. We can simplify that to 5 over 1, or just 5. This tells us that as the independent variable, or number of sodas, increases by 1, the dependent variable, or cost, increases by 5. No matter which 2 points we picked, we would have gotten the same slope because we have a straight line. We can also find the slope value from a table. Let's look at the table we had before. This time we are going to analyze the change between entries, looking at the change in y values and the change in x values. Starting with 1 soda for $5, if we add 1 more soda, we add $5 more to the cost. 1 more soda, $5 more. 4 more sodas, that would be $20 more. 3 more sodas, $15 more. This change that we see between table entries can be used to calculate the slope. Just like we did with the line on the graph, we make a ratio of the change in y over the change in x. We look at each ratio and see that they all simplify to 5 over 1, or just 5, which again is the slope. Finally, we can see the slope in an equation by looking at the coefficient of the independent variable. So in this equation, also representing our soda cost relationship, the slope is 5 or 5 over 1. Again, this tells us how each variable in the relationship changes in relation to the other. So we say the dependent variable or cost increases by 5 as the number of sodas increases by 1. In proportional relationships like this one, the unit rate and slope are the same value.